So what is the definition of the density? Density we are defined by the rule. So density in the, if you ask anybody density, is a mass divided by volume. In details, whenever you are taking it, in terms of the limit, we are writing it down, the mass in the limiting parameter. What should be these values? This delta V tends to 0. So delta V tends to 0. So what is the delta V? How much specific volume you should able to take here? So whenever you are calculating density, if you now for the case of the gas, now your confined space, that is a mass, control mass system you are taking. So in the control mass system, what is the density if you are asking? So how you progress this concept? Whether you go for the individual, so in this mass there are enormous number of molecules is there, enormous number of molecules. So what should be your length to choose? Length scale or volume scale to choose? If you go for the very much small volume you want to choose here, now you're choosing a very small volume here, this is a small volume. So within this volume, how much number of molecules are there? If you calculate, there are n number of molecules. Each molecule having mass is the small m. So you have chosen one small volume. There is n number of molecules. Each molecule having the mass is the m. So what is the total mass? Total mass becomes this. So this total mass divided by the volume will give you the density. You are getting one value of the density. Now if you, the size of the volume, this volume size, if you decrease further, it takes way smaller than the previous one. So first you choose a definite volume. Now you reduce this volume. There are also some number of molecules are there. There's also some n dash number of molecules, and each molecule is m. So here you are getting another some different values. Here you choose the some different. But consideration is your goes on decreasing the your system volume. Now you are decreasing. Initially you are taking some volumes. Now the smaller volumes. Further you can make it small, and you are going towards to 0. You are going towards to 0. So whenever this volume is very small, then what is the guarantee the gas molecules will be there? There may be sometimes for a moment, at some time you can see there is inside the volume, there is a 2 number of gas molecules. After a couple of times, after 5 minutes, you see in this area, same area, having only 1 gas molecules. So could you able to understand the variation of the density is happening here? Whenever there is a 2 molecules, the different density value will come. Whenever here is a 1 molecule, there is different density value will come. Whenever there is no molecule, density value will come 0. So how much smaller is permissible to choose? If you take it tends to 0, so it is not physically you can be able to measure the density. So what the sample you have to choose? How small it should be? So this del V values, should not be 0. It is not correct. Cannot be there. Mathematically, it is correct. Mathematically, it is correct, and we can be able to write it dm by dt. will gives you the density. But actually, if you reduce the volume towards the zero, so there might be uncertainty of the molecules to present in the corresponding volumes, and it causing the error. This kind of the error is known as the microscopic fluctuation. So if you plot here the density and your volume scale of the volume. So this is the volume scale, very small volume scale. Now if the volume scale is you're decreasing towards the zero, the density value will be fluctuating in such a way. Whatever the value of the density you are getting in this way. Okay, in this way. This is called the microscopic fluctuation. After some time, you will get the values properly. After some time, you will get the density linear. And again, you will see some increase and its. So if you plot the density versus the volume, it will be like this way. This is the microscopic fluctuation is occurring. Microscopic fluctuation of the density. Why it is happening? It is happening due to the uncertainty of the molecules inside the corresponding volume. So if you reduce this volume sample, you see the density value is continuously fluctuating. After a corresponding certain distance, the density does not depend on the sample. So this is the delta star. After that, you see this delta star. After that, you see there's not that much changes. So this delta V should be tends to delta V star. So delta V should be tends to delta V star. And here it is some rise because of some density may be rise because of the temperature, some variation of the density because of the temperature, any other concentrator, some mixing of something else, it can cause the change of the density. That is a different. In that zone, you see the density is nearly the same, linear. So del V tends to 0 is not allowable here. There should be minimum sample. So whenever you are writing about the density, basic thing, the density definition will comes in such a way, limit del V tends to del V star lm divided by, sorry, this should not be there. Okay. So you are getting this. That is the actual definition of the density. Hence, you could be able to write it dm by. Now, the density and specific gravity, what is the difference? Specific gravity is the relative concept. The concept is the relative. So relative to what? The specific gravity concept whenever coming, so it is a relative concept. So relative to what? So fluid is either liquid or gas. So if it is a liquid, you have to, the reference liquid is the water. And if it is a gas, the reference gas is the air. Or sometimes hydrogen also. H2. So at the reference of this, you are considering. Mostly the liquid case specific gravity we are talking about. So water. So water, in case of the water, the reference at 4 degree. So the density is taken as in this way, 1000 kg per meter cube at 4 degree water. 4 degree water. So 1 atmospheric pressure. So this can be taken as the reference. So specific gravity, if you are taking it, the specific gravity is given the value. So specific gravity value, if you are given as a for a oil, any oil, the specific gravity of any oil is given 0.9. So what is the density of it? So you will have to write it the oil density, the density of the oil divided by the density of the water at 40%. What is that values? This value is nothing but 1000. So oil is equal to 0.9 into 1000. So 900 kg. That is why the specific gravity we are talking. The basic concept is not that much. The mostly important, whatever I am telling, is that in case of the density, we are not discussing that much regarding, but density at respect to the sample volume, what the volume you have considered is the most important. So minimum volume should not be 0. If you see it's a very rare zone, the density fluctuation will be like this way. You will not get a corresponding density. After that, it is started the linear. And then sudden rise of the upper value. If you plot the density, you'll get in this way. This is the minimum values. You should consider this minimum. Your sample should be this much of minimum volume. And what is that? There is a specific this volume, this length scale. In the length scale, sometimes we are writing it 10 to the power minus 3. In the length scale, we are writing it 10 to the power minus 3. The length scale, it is approx. So volume scale, if you're writing it, there'll be volume scale. If you're writing it, it is a 10 to the power minus 9 mm. It should be minimum. So 1 cubic micrometer should be minimum volume. That will ensure the presence of the molecules inside the system. It will ensure. Otherwise, uncertainty of the molecules will be taken. So here the concept is, we are finishing the concept of the density and specific gravity. One more concept we are talking about, sometimes we are writing it, density into G. That is sometimes called as the gamma. Gamma is equal to density into G. Unit weight. We are talking about unit weight or weight per unit volume. We are talking this thing. This is sometimes called unit weight. With the problem, whenever we are discussing regarding the problem, we will see this. So that is density into G. Mass, density into volume. Already in the concept we have seen, but in detail, some explanation I am giving. Density is like this. So next concept we'll see regarding the bulk modulus.